Okay. So we're going to do some proofs today. These are short proofs. And trying to make it as easy as possible. Proofs take a long time, and there's no direct path. From what I did on my own and what we did in class third period, totally different pathways. It's like driving without a map. We got to get to the same destination, but there's 35 different routes to get there, okay? Proofs are not easy. We're going to do all of these together, and then the backside is your homework. This is what we were doing yesterday. And just solving for x, setting up equations and solving for x, so super easy. And then you just have 3 little statements to complete here, which I'm pretty sure you'll be able to do after we talk through these proofs today. I like using colors, and I think it's very important to mark up your picture. So first one here, when we're doing proofs, what always goes in the first box? The given, very good. So we're going to write down angle 1 and angle 3 are supplementary, and we can totally abbreviate. You must be filling this out, please, as we go. Okay, angle 1 and angle 3 are supplementary. I'm going to mark something on my picture. So it's telling me some information about angle 1 and angle 3. Okay, I don't know what to do with that yet. Our goal is to prove that line M is parallel to line N. So I want to use one of my converse statements. If such and such are congruent, then I'm going to have parallel lines. Or maybe if something is supplementary, then I'm going to get parallel lines. So those are going to be my reasons to get this parallel line. Well, let's see. Let's look at that picture. What do you notice that might be helpful in this picture? 2 and 3 are consecutive interiors? Okay. I definitely think we're going to use that. If we can show that 2 and 3 are supplementary, then we will have our parallel lines. So we're definitely getting there. How do I get angle 2 involved in my proof here? Vertical angles. Very good. Angle 1 and angle 2 are vertical angles. What does that mean if they're vertical angles? They're congruent, yeah. Angle 1 is congruent to angle 2. And why do we know that? Vertical, we have a phrase, our favorite phrase, vertical angles are congruent. Very good. Vertical angles are congruent. That theorem does have a theorem kind of name. It's actually called the vertical angles congruence theorem. I don't know about you, but I'd rather write vertical angles are congruent than vertical angles congruence theorem. One has very little meaning and one is very specific, okay? So I prefer as a teacher to just write the theorems in shorthand versus saying like vertical angles theorem of congruence, okay? That doesn't have much meaning. It's a lot of words, but okay. All right, now, if 1 and 2 are congruent to each other, I would really, as you guys said, it'd be nice to show that 2 and 3 are supplementary. If these are the same, do you think I can, like, pop it in? Substitution, yes, substitution. Hey, angle 2 and angle 3 are supplementary then. And again, we did that just using some substitution. We just plugged it in because these are like equal to each other. So we can just replace one with the other. All right, now if angle 2 and 3 are supplementary, what does that give us? If we know those parallel lines, we get some parallel lines now. Line M is parallel to line N. What's our reason? If consecutive interior angles are supplementary, then parallel lines. Okay. Very good. All right. Proofs are weird. They're kind of fuzzy. We're going to go through. You're going to get used to a little bit of patterning here, but they are different. Later on, we're going to do some triangle proofs, which I think are use a lot of this same stuff, but they're very interesting and a lot more straightforward. All right. Again, what goes in the first step here? Given. So I'm going to smush it in. P is parallel to Q, so I'm going to mark that on my drawing. I want to give some nice big parallel lines because they're giving us parallel lines to start here. So if I have parallel lines, there's a lot of things that I know are congruent right off the bat. Also, let's see, it says angle 1 is supplementary to angle 2. Angle 1 is sup to angle 2, given. Okay, feel free to abbreviate. Yeah. All right. Okay. So they told me, I'm going to mark my picture again, angle 1 is supplementary to angle 2. Are those angles related at all? No. No. There's no connection between 1 and 2. But, interesting here. What about 2 and 3? Is there a connection between 2 and 3? They're alternate interior. Angle 2 and 3 are on our parallel lines. So what are they? They're congruent. Angle 2 is congruent to angle 3, and the reason is because they gave us parallel lines. If parallel lines, alternate interior angles are congruent. If parallel lines, alternate interior angles are congruent. They gave us the parallel lines, so we're going to use that. All right, let's see. I am trying to show that line R and line S are parallel. So I want these orange lines to be parallel. What could we do with 1 and 3? What would they have to be? Supplementary. We want 1 and 3 to be supplementary. Can we do that? 1 is sup to 2. So 3 is the same as 2. So we want 1 and 3. I want to replace that. Can I replace the 2 with the 3? Yeah? Okay. So can we say angle 1 is supplementary to angle 3? What allows me to just replace it like that? Substitution. Okay. Now, if 1 and 3 are supplementary, what do we have? Parallel lines. So I'm looking at the wrong thing. R is parallel to S. How do we know they're parallel? If consecutive interior angles are sup, then parallel lines. Consecutive interior angles are supplementary, then parallel lines.
What is that thingy from the orange?
A squiggle. I messed up.
Oh,
Yeah. R is parallel to S. If consecutive interior angles are supplementary, then parallel lines. Beautiful. All right, let's do this one. I like this one. It's a nice little bow tie picture. All right, what do we start with? The given. And again, I'm just going to smush it in to save space. Angle 1 is congruent to angle 2. I'm going to mark that on my picture. Angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4. Angle 3 is congruent to angle 4. So I'm using colors for my arc marks, my congruence marks. All right, those are given to us. And our goal is to prove that segment AB right here is parallel to segment CD. I want to prove those are parallel. What might help me prove those orange lines are parallel? We do know 2 and 3 are vertical. Maybe we're going to use that. If 4, very good. If 4 and 1, what are these angles? Alternate interior. If we can prove 1 and 4 are congruent, then we'd get those parallel lines. So how do we get there? 2 is congruent to 3. Angle 2 is congruent to angle 3. Why? Vertical angles are congruent. Angle 2 and angle 3 are vertical angles. All right, so 1 is congruent to 2, and 2 is congruent to 3, and 3 is congruent to 4. So what can we conclude? Angle 1 is congruent to angle 4. What property allows us to follow that term? Transitive, yes. Substitution works, but in this case, transitive is what we use when we have a lot of congruent statements, okay? So it follows the sort of the train tracks. 1 is to 2, 2 is to 3, 3 is to 4, so 1 is to 4. Let's just get all the way there. That is the transitive property. All right, so now angle 1 and angle 4 are congruent. What type of angles are those? Yeah, if alternate interior angles are congruent, then parallel lines. And which lines are parallel? Yeah, AB is, parallel, dang it, to CD. Segment AB is parallel to CD. Okay. Okay. Here we go, moving along. Given A parallel to B, right off the bat we have some parallel lines. Line A and line B are parallel, and also angle 2 is congruent to angle 3, given. Angle 2, do angle 2 and angle 3 have anything to do with one another? No, not yet. Okay. We are trying to prove line C is parallel to line D. We want to prove our 2 orange lines here are parallel. What angles? 1 and 2. Okay. If 1 and 2 are congruent, we would have those parallel lines. What kind of angles are 1 and 2? Corresponding. Yeah. Okay. So I think we have a quasi-plan here. That's pretty good. We have parallel lines. What do we know about angle 1 and angle 3? Are they corresponding? All right, they're alternate interior. They're congruent. Angle 1 is congruent to angle 3 because if parallel lines, alternate interior angles are congruent. Angle 1 and angle 3 are congruent. Okay. Now, 1 is congruent to 3, and 3 is congruent to 2, which means, angle 1 would be congruent to angle 2. So there's our angle 1 right there, and there's our angle 2 right there. Why are those congruent? What allowed us to? Transitive. Yeah. Transitive. All right, now you're on to the next step with the corresponding. So if these corresponding angles are congruent, what do we get? Parallel lines. So C is parallel to D, and the reason is because if corresponding angles are congruent, then parallel lines. Okay. Corresponding angles congruent, then parallel lines. Isn't this fun? It's odd. Proofs are odd. They take a very long time to get used to. All right. Okay. R is parallel to S. So those are my lines up here. I'm going to give them some big arrows so that I know that they're parallel. And angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. Do 1 and 3 have anything to do with each other? They don't have a relationship. There is no transversal that's connecting them. So they aren't related right now. So I might have to use it later. But I do have some parallel lines. What do I know because of those parallel lines? 2 is congruent to 1. What kind of angles are those? Corresponding, yeah. Angle 2 is congruent to angle 1 because if parallel lines are given to us, then corresponding angles are congruent. All right. If 2 is congruent to 1 and 1 is congruent to 3, what can we do? Angle 2 is congruent to angle 3 by what property? Transitive. Transitive property of congruence. What its formal name is called. Transitive property of congruence. Isn't that a mouthful? All right. Now, 2 is now congruent to angle 3. What kind of angles are those? Alternate exterior. Good. And if alternate exterior angles are congruent, what do we have? Parallel lines. And there they are. There's our 2 parallel lines that they're on. J is parallel to K because if alternate exterior angles are congruent, then we have parallel lines. Yippee-ki-yay. You ever heard that? Yippee-ki-yay? Yippee-ki-yay. All right. Okay. Last one. Hello. Okay. Bye. Ayrton, your dad's picking up after school. Capiche? Yeah. Okay. All right. Last one. Here we go. Angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. That is given to us. And angle 2 is congruent to angle 3. Angle 2 is congruent to angle 3. Angle 2 and 3 are congruent. All right, this one is weird. They've actually given us some extra information. We are trying to prove that 1 and 4 are congruent. If A and B are parallel, then we would know that 1 and 4 are congruent because they're corresponding. Okay, so I want to get some parallel lines. I know angle 2 and angle 3 are congruent. Would that give me some parallel lines? Yeah. A is parallel to B right off the bat, just with this information that 2 and 3 are congruent. What kind of angles are those? Alternate interior. If alternate interior angles are congruent, then we have parallel lines. So now I know right off the bat that A and B are parallel. And if A and B are parallel, what do I know?
Angle 3 and angle 4 are congruent.
1 and 4. Yeah, 1 and 4 actually. Angle 1 right off the bat is congruent to angle 4 because if parallel lines corresponding angles are congruent. So they actually gave us more information than we needed. Oh yeah, we sure did. Well, so you would have had to prove that C and D were parallel first. So that's what's hard about proofs. There are 8 different ways to do this one proof. Okay, but there's a lot of steps the other way. This was the shortest. Okay, ladies and gentlemen, fantastic. You need to finish the other side here. It only literally takes 5 minutes, and I'm just going to get you started. Use the diagram to find the value of x that makes our lines parallel to one another. If the measure of angle 1 is 30 and the measure of angle 7 is 2x plus 10, what kind of angles are those? No, not vertical. Alternate exterior angles. And if alternate exterior angles are congruent, so 30 is equal to 2x plus 10. Can you solve for x? Yes, you can. Those are alternate exterior, need to be congruent. All right, you got it. Finish her up and turn her in. And don't forget to turn in yesterday's homework.
Oh, I did that already.